Here's a claim that sounds bold, but isn't. Without the Monte Carlo method, modern AI simply would not exist. AI, at its core, is the study of high-dimensional probability distributions. And the problem with high dimensions? The math becomes unsolvable. The integrals explode. Physicists have faced this exact problem for decades, calculating interactions in quantum systems too complex for pen and paper calculus. AI faces the same wall, figuring out the expected value of a reward or a loss function across a state space that's essentially infinite. The solution, in both cases, is Monte Carlo. Here are the three pillars where Monte Carlo is the engine driving modern AI. Pillar 1. Monte Carlo Tree Search. The algorithm that let AlphaGo beat the world champion at Go. The closest thing AI currently has to imagination. Here's the problem it solves. In a game like Go or chess, there are simply too many possible moves to calculate the perfect one. The branching factor, the number of paths the future could take, is astronomically large. You can't check every path, not even close. So instead of calculating everything, the AI imagines thousands of random games. It picks a move, then plays out the rest of the game with random decisions, simulating all the way to the end. If it wins, it marks that first move as promising. Then it does this again, and again, thousands of times. The move with the highest win rate across all those simulations, that's the one it plays. Think of it like this. Instead of solving the equations of physics to find the most efficient path, you throw thousands of random particles at the problem and see which trajectory keeps coming out on top. Statistics does the heavy lifting. Pillar 2, the creative engine. And this one affects everything you've seen come out of AI in the last few years. When a large language model writes text, it doesn't just pick the most likely next word. It maintains a probability distribution over every possible word. Take a simple sentence. The cat sat on the... Maybe Matt gets 70% probability, hat gets 20, lap gets 10. The naive approach, always picking the highest number, produces text that's boring and repetitive. So instead, the model samples from that distribution. It rolls a digital die weighted by those probabilities. That randomness is not a bug. It's the source of creativity. Diffusion models, the technology behind AI image generators, take this further. They start with pure noise, pure static, and iteratively remove that noise, step by step, until a coherent image emerges. The mathematical framework underlying this process is called Langevin dynamics, a Monte Carlo method originally developed to simulate how molecules move through fluids. The images you see aren't calculated, they're sampled into existence. Pillar 3, the learning engine. This is where Monte Carlo connects directly to reinforcement learning. The question is deceptively simple. How does an AI know if a particular situation is good or bad? Say the agent is in a video game, facing a boss. Is that position worth being in? You don't try to calculate it from first principles. You don't model the geometry of the fight. You do something much more powerful. You just play it out. Let the agent run from that state all the way to the end of the game. Add up all the rewards it collected. Do that 100 times. Average the results. That average is the value function, a direct measure of how good that state is, derived entirely from experience. This is model-free learning. The AI doesn't need to know the rules of physics. It doesn't need a handcrafted model of the environment. It learns the value of every state it encounters just by experiencing them, statistically, empirically, over and over again. So here's the picture. Monte Carlo is the reasoning engine, powering the strategic imagination of AlphaGo and every game-playing AI that followed. It's the creative engine, the randomness that lets language models write with genuine novelty, and the physics that turns static noise into a photorealistic image. And it's the learning engine, allowing AI to assign value to experience without needing to be told the rules of the world. It's not a trick. It's not a shortcut. Monte Carlo is the statistical backbone that makes modern AI possible.